This question is from Multithreading, and the question is, how do you create a thread pool? So before answering how we can create a thread pool, I just want to understand you what is a thread pool and what are the advantages of thread pool. Okay. So a thread pool is a collection of pre-initialized threads that can be used to execute tasks concurrently. So instead of creating the threads at runtime and assigning the tasks, we can create them before, and then thread pool can take care of assigning the task using those threads. So alternatively, if you create a thread manually, it's really a expensive operation. Also, the manual threads has to be handled by the user, that is their life cycles, which is a very tedious task in real time, right? So for your information, I'm just listing the different kind of operations we need to handle or thread pool has to handle when a thread is created. So usually those operations are like resource allocation, context switching, thread stack, thread initialization, synchronization overhead, and garbage collection. So this is why instead of creating a manual threads, we need to go for a thread pool which system can handle itself, or the framework provided by Java can handle it. So first I'm showing you example here how we can create a manual threads. I'm putting a simple for loop and I'm creating 1,000 threads and starting them. You can go through this code at any time, no issues. Just before that, I will just show you how these manual threads work. So usually our program will start from the main thread, right? And in our main, we have written a for loop to create 1,000 threads, right? So these 1,000 threads created as subthreads from the main thread, and all these threads we say Java threads. From the other side, in the perspective of our computer system or the OS, the number of OS threads depends on the number of cores your system has. Suppose your system has 4 core CPU, then it can support up to max 4 OS threads at a time. Similarly, if your system is a 8 core CPU, then it can support up to 8 OS threads simultaneously, right? So usually one Java thread occupies one OS thread, okay? Which means whenever we assign a task to a thread that is Java thread, it utilizes one OS thread which is very costlier, okay? So now imagine we have 1,000 threads and we have only 4 OS threads, right? Suppose 4 threads were occupied the 4 OS threads. That means now no OS thread is available. And out of these 4 Java threads, 3 went to sleep because they are waiting for some IO operations or the IO resources we say. So exactly at this time, you have to allocate the OS threads for the waiting threads. But for that, you have to fetch the OS threads which are already occupied by the sleeping threads. So with the 1,000 manual threads, it's not easy to allocate and reallocate and to free the threads based on their occupancy at the runtime. So you can answer this to the interview. This is the situation where this thread pool is handy compared to the manual threads, as thread pool has the capability to automatically do all these things for you. Now let's explore the mechanism of the thread pool. So coming to the thread pool, you can say thread pool is a container where we will create a number of threads in it, and all these threads were assigned to the respective tasks. Since these threads were associated with the thread pool and the ExecutorService framework already provided the mechanism to automate all the manual tasks we need to do when we create the manual threads. So that is we already discussed, right? So here you can see the tasks were in the queue and threads are accessing the task from that queue. So whenever any task is completed or it is went into the waiting state, the thread will pick up another task from that queue, and so the time will be saved here, right? Also, the overhead of monitoring and managing of these threads will be taken care by thread pool only. Here I am writing the code to create the threads using the thread pool. We are following the same thing, nothing difference. Only here difference is we are using a executor service and we are submitting the each created thread to that. So while creating the executor service object, we're already defining the number of threads we required in the pool. You can see executors.new fixed thread pool and we're passing the number 1,000, right? So now that executor service has capability of holding the 1,000 threads, then for each thread we're creating a task and we're assigning and submitting, right? I hope now we are in a position to understand what is the difference between creating the manual threads or using the thread pool. So now you can take a note of this code for the thread pool creation. On the screen now, I'm just popping up what thread pool will do for us in the backend. We are already discussed this. You can see the points: resource management, performance, scalability, flexibility, error handling, monitoring and tuning, simplifying the code, task queuing, and shutdown management. So overall, the executor services leads to more robust, scalable, and maintainable concurrent applications. So apart from the executor service and thread pool executor, we have also other ways we can create a thread pool, such as fork join framework, completable feature. Also, we have a custom executor service. So that is all about the creation of thread pool and how it works. Okay. Now let's move on to the next question.